Hi guys, this video is on solving systems of inequalities. Okay, so systems of inequalities are going to be done on an XY axis where there's a Y, which is like a number line going vertically, and an X, which is a number line going horizontally. It doesn't hurt to quickly review what it's like to graph these on just a number line with one variable, X. In this case, you would say X is less than -2. You have an open circle at -2 to indicate that -2 is not included, and we want to show everything that is less than that. So this would be that set of solutions. If we had x is greater than 5, we would start right here at 5, open circle, because again, x is not included, 5 is not included in x, and any point up here is an answer. None of these points in between -2 and 5 are solutions. So now we're going to go to show the systems in an xy plane. This has one expression written in terms of y, one expression written in terms of x. So it doesn't hurt to recall the slope of this line. It could have been written y is less than 0x plus 5. The slope of that line is 0. It's going to be going about like so. This is not written in slope-intercept form. It can't be, because that line has no slope. It's where x is equal to -3. Okay? More precisely, everything up to -3, but not including -3. Here's what that might look like if I had a better drawn graph. Okay, so this is the first equation. X is greater than or equal to -3. So I guess it actually is equal to -3. You notice this line right here is a solid line. It includes the -3. It's the equivalent of if we had said on this x number line, I'm going to darken in at -3 and show everything to the right because x is greater than -3. But because we have a y-axis, it's all these points over here where x is greater than -3. This would be the second part of the system where x is less than 5. Note, it is less than 5. It is not equal to 5. Therefore, this is a dotted line showing that you can go right up to 5, but you cannot include 5. If this was simply y being as a number line, it would be an open circle at 5 and an arrow pointing to all the solutions, all the values that will be less than 5. Now we've got to put the two together. Okay, so this is a graph of both these conditions of the system graphed at one time. Over here, all the answers for x greater than -3 or equal to -3. Over here, all the answers where y is less than 5. You'll notice there's a region which has no shading. This has no solutions for either one. This one has the solutions for only one of the conditions. The right here has the conditions for only one of the systems. It's the double shaded region that meets the conditions for both equations, for both inequalities. It's important to note that if this had been an equation, a system of equations, that point right there, -3 on x, 5 on y, would be the answer. In this case, that is not a valid answer because this is a dotted line and you cannot use 5. You could use -3, 4, or -3, 4.9. That would work, as would any other point over here would work. The easiest way to test if you've shaded correctly is to test for, in this case, 0, 0. You say to yourself, is it true that 0 is less than 5? Yes, it is. You say to yourself, is it true that 0 is greater than -3? Yes, it is. Therefore, you have shaded correctly because 0, 0 passes the inequality test, and it also passes the double shaded image test. This is a much more common system of inequalities. Both of these equations are written in slope-intercept form. You can kind of imagine that the first one has a slope of 2/5. It's going to be rising slowly and has a y-intercept of 5. The second one has a slope of -1 because it's -1x. And it has a y-intercept of -2, so it's probably going something down like this. Let's see what they look like when you actually graph them. Okay, so here's the first condition of this system. The slope is 0.4, also known as 4/10, also known as 2/5. If you run over 5, you're going up 2. If you run over 10, you're going up 4. The y-intercept is 5, so it's crossing at 5. This is less than, it is not equal to, therefore it is a dotted line. Any point on that line is not a solution, it happens to be the border. Everything over here is the answers. It should be true that 0, 0 works in this equation, since it's in the shaded region. Try it out. 0, is that less than 4 times 0 plus 5? Is it true that 0 is less than 5? Yep, that's true, so you shaded the right side. Now we're going to lay on the second graph. Here's the second graph. The slope of this graph is -1.5. It's dropping. The y-intercept is not written out, but it's implied. Y-intercept is 0. There's the y-intercept. It's got a slope of -1.5. If you go over 1, it's going to be dropping 1.5. If you go over 10, it's going to be dropping 15. Any point on this line is a solution because it includes it. It says y is greater than or equal to. An important thing to notice in both of these cases is that these equations are written for y, and that is usually the case. Y is the vertical axis. When you say y is greater, basically that means you're going to shade above any point on the line. So in the second one, y is greater than -1/2 x. You're going to go, oh, here's that line. Y is greater than, where's y greater? And you're going to shade upward because y is greater. In the first one, y is less than 0.4x plus 5. This is where it's equal to 0.4x plus 5, but you have to show where it is less than. That would be down in here. Once again, this area meets none of the conditions. This area meets one condition. This area meets one condition. The double shaded area is the area that is the solution to the system. Every point in here is true in both inequalities. Once again, this point right here, the intersection, which would be the only answer if we did a system of equations, is not a solution because this line is dotted. So that is not included in the solution for both. 0, 0 is a solution because 0, 0 is on the line here and it's below the dotted line. Here is a basic system of linear inequalities. Please graph both of these on one xy axis. Note that both of these are in slope-intercept form. The first one has a hidden slope because its y is less than 0x minus 3. If you have to, do a table of values. If you're able to, you can just go straight to the y-intercept and use the slope of 1 to guide you, straight to the y-intercept. Use the slope of 0 to guide you. Go ahead, pause the recording and graph it. Okay, so hopefully you got an answer that looked something like this. The first one, y is less than -3. Here's where y is equal to -3. It's everything below. It is not equal to -3, so it's a dotted line. Second one has a slope of 1, y-intercept of -5. Crosses right here, goes up like so. But this says y is greater than x minus 5. This is the place where y is equal to x minus 5. Every point on here, take the x value, 10, take away 5, 5. Okay, but this is saying it's got to be greater than that. So 5, 10, 5 would not be an answer. 10, 6 would be an answer. It says y is greater than, you're shading everywhere above the line because y is all about up and down. This one you're shading everything below because this y is about up and down. This is lesser on y. no answers are here. This works for one, this works for the other. This is the true solution of this system of inequalities. Once again, this intersection point would have been the answer if it was a system of equations, but since this is inequalities and it says less than and greater than, it does not include that intersection point. So everything in here are your answers. You must color all those in, and they continue on forever in that section of the plane. Okay, for your homework, here are two separate systems of inequalities. Please draw two separate XY graphs. Draw in the border lines and shade all regions of the graph that are solutions. Good luck. Okay, so here's your homework. You have two different systems here. Each one of these systems needs to be graphed in its own coordinate plane. You should test your answers. Test. For example, if 0, 0 is in the solution region, that is the easiest point to test to make sure that it is true for both equations. Okay, good luck. Please use a ruler. Be nice and tidy because the borders on these graphs matters quite a bit.